This is the video for section 13-2 on multiplying and dividing rational expressions for accelerated geometry. Day 1's video, we will just be looking at multiplying, and tomorrow's video we will look at dividing. So key vocabulary in this lesson is rational expressions, and a rational expression is just a quotient of two polynomials. So for example, you could have x squared minus 4 over x plus 2. You could have 10 over x squared minus 6. You could have x plus 3 over x minus 7. Anything in the form of two polynomials over top of one another is what we call a rational expression. And on this last one here, the k could be a constant. So like 1 over x is still a rational expression. So in our first couple of examples, it says simplify and identify any x values for which the expression is undefined. So anytime you have for which the expression is undefined, I'm going to do that first before I simplify, because sometimes we forget and we don't get all of where it's undefined because we use the simplified answer and not our original. So to get where it's undefined, we're going to take the denominator and set it equal to 0 and solve for x. The fourth root of x would be x. The fourth root of 0 is 0. So this equation is undefined at x equals 0, which tells me that x cannot equal 0. That's the domain restriction. Now for simplifying, we're just, what's 10 over 6, what can that be reduced to? And they're both divisible by 2, so that would give me 5 over 3. And then if you remember with exponents, you subtract. So 8 minus 4 is 4. And that's positive, so it's going to go up top. Basically, whichever of these is the biggest number is where the result's going to go. So this would be my final answer for example 1. Example 2, so if I do where it's undefined first, we're going to take x squared plus 2x minus 3 and set that equal to 0. This can factor. Two numbers that multiply to negative 3 and add to be 2 would give me x plus 3 and x minus 1. So that tells me that x is negative 3 and x is positive 1. So I know that x cannot equal negative 3 or 1. And then when I simplify, we already know the bottom factors to x plus 3 and x minus 1. The top, what are two numbers that multiply to negative 2 and add to be 1? That would be x plus 2 and x minus 1. So if you notice, x minus 1 is on the top and the bottom, so I can cancel them out. And my result would be x plus 2 over x plus 3. And this is an example where if I hadn't done the undefined first, here I would have just said that it was undefined at negative 3, but in reality, it's really undefined at negative 3 and 1. So this would be part of my answer, and this is part of my answer. Okay, it says caution. When identifying values for which the rational expression is undefined, identify the values of the variables and make the original denominator equal to 0. That's kind of what I was saying before, where you do the undefined before you simplify. Example 3, simplify and identify any x values for which the expression is undefined. So I'm going to do the undefined first. X squared minus 2x minus 8 equals 0. So two numbers that multiply to negative 8 and add to be negative 2 would be negative 4 and positive 2. So that tells me that x is 4 and negative 2. So I know on my answer I'm going to have that x cannot be 4 or negative 2. That's the domain restriction. And I already know that the bottom would factor to x minus 4 and x plus 2. The top, what I would do on the top first is put it in standard form. So that's really negative x squared plus 4x. Then I can pull out a negative x here. which leaves me with x minus 4. And then you see that the x minus 4 is canceled. So I'm left with negative x over x plus 2. At this point, I want you to pause the video and try these next 3 problems for yourself and see if you can do them. Okay, so hopefully for example 4, your final answer came out to be 2x to the 9th, where x does not equal 0. So I got the undefined by setting 8x squared equal to 0 and solving for x. 16 over 8 reduces to 2, and 11 minus 2 is 9. On example 5, the top doesn't factor any further. The bottom factors to 3x plus 4 to x minus 1. The 3x plus 4 cancels. And anytime you have everything up top that cancels, that means you have a 1 up top. So the final answer here would be 1 over x minus 1, and our domain restrictions would be that x cannot equal 1 and x cannot equal negative 4/3. Because if you set the denominator factors equal to 0, you get that x is 1 and x is negative 4/3. And I've shown you here the steps that I went through in order to factor the denominator if you needed a reminder on how to do that. For example 6, the top factors to 2x plus 1 times 3x plus 2. The bottom factors to 2x minus 3 and 3x plus 2, so the 3x plus 2 cancel. So your simplified answer is 2x plus 1 over 2x minus 3. And your domain restriction would be that x cannot equal negative 2/3 and positive 3/2. And down below here, I have gone through the steps of factoring the numerator and the denominator in case you need to see what I did. Okay, steps to multiplying rational expressions. Step 1 says to factor all numerators and denominators completely. Then you're going to divide out, which is another way of saying cancel out common factors that are both in the numerator and the denominator. And then you're going to multiply numerators and multiply denominators. Remember, when you multiply fraction, you multiply straight across. And be sure that the numerator and the denominator have no common factors other than 1. So on example 7, I'm going to look at this. It says to multiply, assume that all expressions are defined, which means we don't have to worry about finding when it's undefined. So if I look, I can see that 10 is divisible by 2 because this is really 5 times 2. And 9 can be broken down to 3 times 3. So that I can go ahead and cancel this 3 with one of these 3, and this 2 with the 2 that's down here. Then if you can't see what already cancels, like you have an x to the 3rd here and an x to the 3rd here, so they're going to cancel, and I'll show you a different way of working this in just a second. Then you also have anything else here? You would have the 5 and the 2 on the x. So 5 minus 2, if I cancel those out, would leave me with a 3 here. Remember that when you multiply, you add exponents. So that would be 3 and 4 would give you 7. So these together cancel this y to the 7th. And then you're left with y to the 5th on the bottom. So then your final answer here would be, if you multiply straight across, you have a 5 left there. Let me circle this. You have a 5 here. You have your x to the 3rd here. And then on the bottom, you have a 3 and a y to the 5th. Now, let's say you didn't understand anything I just did. So we're going to start completely over. When you multiply fractions, you multiply straight across. So up top, you would have 3 times 10, which is 30. When you multiply, you add exponents. So 5 and 3 make 8. 3 and 4 make 7. 2 times 9 is 18. 3 and 2 make 5. 7 and 5 make 12. Then it's a matter of reducing this. So 30 divided by 18, they're both divisible by 6, would leave you with 5 over 3. You subtract exponents when you divide, so 8 minus 5 would leave me with a positive 3, so that means it's up top. 7 and minus 12 is a negative 5, it's a negative, so that means it's going to be on the bottom and be positive. And you realize that you get the exact same answer as if you simplified as you worked it. Example 8, first thing the direction said to do was to factor the numerators and the denominators. So x minus 3 doesn't factor any further. I'm going to put that in parentheses just so I remember that that's one term. On the bottom, I can factor out a 4, which leaves me with x plus 5. X plus 5 doesn't factor, so I'm going to leave that as it is. X squared minus 9 is the difference of squares, so that's x plus 3 times x minus 3. Cross out what's on the bottom and the top. It doesn't matter if it's on one side or the other as long as it's up top. Like, for example, the minus 3 cancels with the x minus 3 over here. One's up top, one's on the bottom. X plus 5 cancels with this x plus 5. Then there's nothing else up top, so I can't cancel anything else. But you have to remember, if everything cancels up top, you really have a 1. On the bottom, you have 4 and x plus 3. So this could be seen as an answer, or if you FOIL this, not FOIL it, but distribute it back out, this would be an answer. So depending on who wrote the answer key, or if it was a multiple choice test, it may have this as your answer or it may have this as your answer. Both of these are correct. Okay, at this point I want you to pause the video and try these two examples for yourself. So hopefully on number 9, example 9, that you got 2x to the third all over 3, depending on how you worked it. First way, you could realize that this x cancels with this x. 20 over 2 reduces to 10. 10 over 15 reduces to 3 on the bottom, 2/3 basically. And then x to the 7th, x to the 4th, if we subtract them, the 4th would cancel and that would leave me with just x to the 3rd. So then up top, all you have is the 2 and x to the 3rd, and on the bottom, you just have the 3. Or if you did it the other way around, if you multiply the top straight across, you would have 20x to the 8th over 30x to the 5th, and 20 over 30 reduces to 2/3, and you subtract them, and you're left with a positive 3, so it's up top. Oops. Example 10, factor the tops, or the numerators. You have 10x, 10 parentheses x minus 4 for the top of the first one, the numerator. Then the denominator, you would factor to x minus 2 and x minus 4. The numerator of the second one does not factor. The denominator of the second one would factor to 5 parentheses x plus 3. The x plus 3 cancels. The x minus 4's cancel. So when you multiply straight across, you get 10 over 5 times x minus 2. But 10 over 5 can reduce to 2 over 1. So your final answer should be 2 over x minus 2.